In this video, we will revise machine learning related concepts using easy to understand relatable real life examples. So let's get started. A is the algorithm. So imagine a recipe for a dish where each step tells you what ingredients to use and in what order. An algorithm is also a set of instructions for a computer to follow to solve a problem or complete a task. B is a bias. So let us say you are choosing a restaurant based on the review. So if you only consider reviews from the friends or family, you might have a biased opinion. Similarly, a machine learning model can have a bias if it is trained on a data set that does not represent the entire population, leading to inaccurate results. C is the classification. So imagine categorizing fruits in a market. So classification is a machine learning technique that assigns an input like a fruit to a predefined category like apple or banana. D is a decision tree. Now decision tree is like a flow chart that guides you through a series of choices until you reach a solution. In machine learning, a decision tree model predicts an output by following a set of rules based on the input data. E is the ensemble learning. So think of a group of friends giving advice on what to wear for a party. Ensemble learning combines the prediction of multiple machine learning models to make a more accurate decision. F is the feature. Now features are the attributes or characteristics of an input. In a credit scoring model, features might include income, credit history, and debt to income ratio. And these features help the model make predictions about the likelihood of defaulting on a loan. Then G stands for gradient descent. So imagine a hiker trying to reach the bottom of a steep valley. So the gradient descent is a method used in machine learning to find the optimal solution by iteratively adjusting parameters in the downhill direction. H is the hyperparameter. Now hyperparameters are adjustable parameters that controls how a machine learning model behaves. For example, the learning rate in gradient descent is a hyperparameter that determines how quickly the model adjusts its parameter. I is the instance. Now instance is a specific observation or data points. In a data set, each row represents an instance containing features and a corresponding output. J is the Jacobian matrix. Now this Jacobian matrix is a multivariable functions equivalent of a derivative. It's a squared matrix containing partial derivatives of the function output with respect to its input variable. In machine learning, Jacobian matrices are used during optimization processes to evaluate the local linearity and stability of the model. So think of it as a tool that helps optimize the parameters of your machine learning model for better performance. K is the K-nearest neighbor. So imagine finding the best suited restaurant for a particular cuisine based on your friend's recommendation. So this K-nearest neighbor is a machine learning technique that predicts an output by finding the K closest instances in the training data and averaging their output. L is the logistic regression. Now this logistic regression is a machine learning method used for binary classification. For example, predicting whether an email is spam or not. It models the probability of an output occurring based on the input features. M is the machine learning, which is a field of study that focuses on building algorithms and models that can learn from data to make predictions or decisions. It involves training models on large data set and fine-tuning them to improve their accuracy and performance. N is the neural network, which is a type of machine learning model inspired by the structure and function of human brain. They consist of interconnected nodes or neurons that process and transmit information to make predictions. O is the overfitting. So imagine a tailor making a custom suit for a single person. So overfitting occurs when a machine learning model is too complex and memorizes the training data, leading to poor performance on new unseen data. P is the precision, which measures the proportion of true positives among the predicted positive instances. In a medical diagnosis, precision would indicate the proportion of patients accurately diagnosed with the disease among those diagnosed positive. Q learning. Now Q learning is a type of reinforcement learning where an agent learns to make optimal decisions by exploring and exploiting its environment. It is often used in robotics and game playing scenarios. Then random forest. The random forest is a machine learning technique that builds multiple decision tree on different subsets of data. So by averaging the predictions of these trees, random forest model reduce the risk of overfitting and improve overall performance. S is a sport vector machine. So imagine a line separating apples from oranges in a grocery store. Sport vector machines are a type of machine learning model that finds the best fitting hyperplane to separate data points into different classes or categories. Then T is the training data. Now training data is a set of input-output pairs used to train a machine learning model. Now the model learns patterns and relations in the data, which it then uses to make predictions on unseen data. U is the underfitting, which occurs when a machine learning model is too simple to capture the underlying patterns in the data. In this case, the model will perform poorly on both training and testing data. V is the validation, which is the process of evaluating a machine learning model's performance on unseen data. This helps to ensure that the model generalizes well and can make accurate predictions on new data. W is the weight. In the context of machine learning, weights are numerical values assigned to the features of an input. They represent the relative importance of each feature in predicting the output. X cross validation, which is a technique used to evaluate the performance of machine learning model into the multiple floats. And here this process is repeated multiple times to ensure a fair and accurate assessment. So we can say this cross validation is a technique used to evaluate the performance of machine learning model by splitting the available data into multiple folds, training the model on some folds and evaluating it on the remaining folds by repeating this process multiple times to ensure a fair and accurate assessment. Y is the Yahoo, which is an exclamation of excitement or satisfaction. In the context of machine learning, this could be the feeling of achieving a high level of accuracy and performance on a machine learning task. Z is a zero-shot learning, which is a type of machine learning that enables a model to make predictions on unseen classes or concepts. This is achieved by using a pre-trained model and relying on textual description or metadata to make predictions. So to summarize this, we can say machine learning is a vast field with numerous concepts and techniques. By understanding these terms and concepts, you can better appreciate the power and potential of machine learning in solving real-world problems. Thank you.